which is the combination of series and parallel network. So you can see over here that R3 and R4 are in series to each other, and then these two are in parallel to R2. So what we do in reduce and return approach, first we reduce the circuit such that if there is any series part, then we take the equivalent of that series part. For example, this is series part, and this is independent part, not the dependent on anyone. So we reduce it to one resistor. So R3 and R4 are in series. We make it one, then it means that R3 plus R4 is equal to, we name it like R dash. You can see over here, the combination of these two are taken as R dash, which is equal to R3 plus R4. Then what we can see, if we make it one, like R dash, then that R dash would be parallel to R2. And if it is parallel to R2, then it means that we will again reduce this parallel part to one resistor. And this time we will name it as RT dash. आप लोग अपने मर्जी से इसको कोई भी नाम दे दे, मैंने इसको RT dash का नाम दिया हुआ है. The RT dash, because it is the combination of R2 and R dash, and we know that if two resistors are in parallel, then we use the formula R multiply R1 multiplied by R2 divided by R1 plus R2. Here, instead of R1 and R2, it is R2 and R dash. So in short form, we write it like this: R T dash is equal to R2 parallel to R dash, and we reduced it to one over here. Again, if you see that these two resistors came into series with each other, so simply we will add these two to make it one. So that would be RT. So RT is equal to R1 plus RT dash. So we made it one over here. So if we made it one over here, then now it is the simplest circuit where there is one of the voltage source and one resistor in with it. So simply for determining the current, that is the source current IS, we will apply the Ohm's law. I is equal to V divided by R. Here instead of V there is E, and instead of R there is RT. So I is equal to E divided by RT, which is the source current over here. So we can find current over here if we already found the total resistance. Next, so up to this point, it is reducing. And then return, if we want to know the current over here or the voltage over here or here, then it means again we will expand this circuit to its original position or to the target point. So we find out current over here, we find the total resistance over here. Again, now we can again expand it, or you can say that we will return the circuit. So again, what we will do from this one resistor, again we will make the two resistors, as you know that from this step we came to this step. Again from this step we will go to that step, that is step number C. So step number E and step number C is actually the same. But now the advantage is that we already know the value of current. So if these two resistors are in series to each other, you know that the value of current in series network will remain same. So we already know the IS value, and IS will also be there inside the RT, like over here RT dash. Now what we do, if we want to find out current into this resistor, in this resistor, then or you find out the voltage in this resistor, that then what you will do. So there again you will expand your circuit, like over here from this step you will go to this step. It's the same as from this step you go to this step, and from this step you can go to this step. Again we will go in the reverse direction, as from here we are coming to this, and again we return back to this position. So from this network again I will make this circuit. But now I know that from here to here, the voltage value, what is the voltage value? So here we can find the voltage because we know the value of current over here. And if we want to find out the voltage over here, we know that V is equal to IR. So what is the R value? R value is the RT dash and the I value is IS. So by this way, we find out the voltage over here. And if you find out the voltage over here, it means this is the voltage from this point to this point in the original circuit. So again, we expand the circuit, we return the circuit to the first original position. So if we return it, now we know the voltage from this point to this point. If you want to find out voltage over here or here, you can apply the voltage divider rule and you can easily find out the voltage over here. Because now the total voltage from here to here, you will take, and from this then you will apply the voltage divider rule to find out voltage over here. So you know that voltage divider rule says that in a series part, this is the series part. If you find out if you want to find out the voltage in a component, then you will take the resistance of that component divided by the total resistance of that series part multiply by the total voltage coming to that series part. So the total voltage from here to here, the total series part is from here to here. So now this is R4 divided by R3 plus R4 multiplied by V2. V2 is from here to here. So by this way, you find out the voltage over here. If you want to find out the voltage over here, the same formula you can apply, but instead of R4, you will put R3 over here. But if you determine the value of R4, then R3 is very easy. You do not need to apply the voltage divider rule again. It would be lengthy. What you will do, you will take this voltage from here to here, and you will subtract this the voltage from here to here from this voltage, and you will get this voltage. Perhaps the voltage from here to here is V2, and from here to here is V4. Then V2 minus V4 is equal to V3. Is there any problem? Any question?